How can I connect this one? Like this. Can I connect this one? I don't know. Like, is there a cable or something? Yeah. So yeah, there's a converter, but like, is there any way to connect this? Oh, okay. Okay, all good. And the mic is always here, right?
Yeah.
There is no alternative.
No.
Okay, all good. Okay, it's all good. Like if I cannot walk, then
Yeah.
it doesn't matter.
It works.
Yeah. Do I start now? So I guess we can start right now a bit. So yeah, I'm now starting. Hi everyone, my name is Talib. I'm a DevRel engineer at Citrea, and we're building something interesting. And in this short session, I'm going to explain like what we're doing shortly, and then what our tracks are, and maybe like how can we help. So the Citrea is essentially an EVM-compatible ZK-Rollup on Bitcoin, and like if you're not aware of these concepts, I think first we should dive into what do these mean, and like we can talk more on these. So like blockchains are basically decentralized machines. It's like a combination of multiple machines that does some computation. It's a network of computers at the end of the day. And we're building these because we believe they're a new whole open world of privacy, innovation, and freedom. Even though we failed a bit, like since the launch of Bitcoin, still we believe there's a long way to go, and still we can achieve all these. And if you were to, look back on like how all these things started, like Bitcoin was obviously like the implementation. Like there were ideas of implementing a digital currency in the world after all the tech boom, and then like there was eCash, DigiCash, B-money, Hashcash, like different ideas. Some of them being centralized, some of them their own trade-offs. But at the end of the day, people were searching for some new ideas to carry out all these operations in a more digital way. And then like the 2008 financial crisis hit, and then like the idea of Bitcoin was born. It got registered, and then the white paper, which we probably all of us know about a bit. If you're not, please go check it out. It's a really simple and nice paper. And then the Bitcoin white paper was published, and then like the client implementation got running in 2009. And like then, another keyword that we all know is the Ethereum. Like, we know Bitcoin is cool, but like Bitcoin is mostly used for the purpose of money. It's like you can submit money to your friends, you can receive money, send money, you can do a bit of programmability, but like if you want to build use cases of loans, if you want to build use cases of different stuff, then Bitcoin is not sufficient for that, because Bitcoin script does not allow you to do expensive heavy computation. Actually, like most of the blockchains don't, but like it's quite limited in that sense, and you can only submit money. So there was a need to do more stuff. There was a need to bring more parts of traditional finance into the ecosystem, like into these digital cash. So like the Ethereum basically enabled this. Now you can do with the EVM ecosystem and on the Ethereum like much more expressive stuff, much more general stuff, like any kind of DeFi primitives, like taking loans and adding some programmability, generating more and more token types and different stuff, even to the point that verifying ZK proofs, which are some expensive computation that you can utilize. So for example, we have our Bitcoin Lite client contract. It is a smart contract. It's basically just like Python or just like C++. It's a piece of Solidity code that runs in a set of computers and that verifies the execution of Bitcoin transactions. So like the Ethereum was born based on some needs, and this need was doing more with the money, like instead of just sending and receiving. So yeah, blockchains are cool. Like they're pretty useful. They have many applications as much as their EVM, their virtual machines allow, and they're cheap. Like compared to banks, like if you try to send I don't know $2,000 using some bank, then you pay like a huge ton of fees to the banks. But like, you know, on blockchains, this is like, depending on the trade-offs in security, this is really cheap. And like some blockchains can also be privacy first, even though we don't see them too much. Hopefully we will see more. But like, there are also caveats of blockchains. Like, they're not really super enough as we want them to be. Like, you know, there is this famous trilemma called blockchain, like the scalability trilemma, essentially, like the, you know, that's how I call it, at least. This is a trilemma, like, the more computers you get, the secure your chain is, but then it starts to get slow or more expensive. Or like, if you make a smaller chain that executes fast, then you basically leave out a bit of decentralization. So it's all these kind of trade-offs, and that's why they call it like blockchain trilemma. But like, one solution that tries to overcome this, at least, is like, not even to the sense that like you would think, but it in a different way, is rollups. Rollups are types of scaling solutions in which you make a faster and smaller chain, but you also post your data into another blockchain that who can verify your chain execution. It is like, let's say I make a chain called T-chain, and I make it a small network. Then people might be skeptical in the sense that, you know, can these people harm our money? Can these people harm us in the way that steal our funds or whatever? So like, all these stuff that you see in this, like, you know, event are just kind of scalability solutions, essentially, especially if they're infra, who is trying to make a much secure and theoretically much more promising solutions. And one idea is rollups again. And rollups are like, you know, you make a chain that puts its data into another chain, and as long as this other chain keeps preserving your data, then like everything is okay, because you can just use this other chain as a source of truth. And this other chain also has some computation that verifies your execution. It is like, I make T-chain, I post the data of T-chain into, let's say, Bitcoin, and then I also verify the execution of this T-chain in the Bitcoin as well. So as long as people don't touch Bitcoin or like don't break Bitcoin, then I can always verify that everything is correct to the public just using the Bitcoin, so that people can use T-chain more, in a more better and securer way. Like, they can trust me more, like. And this is the idea of rollups. Like, you basically do some things faster and then verify it on another decentralized network, using the data and like perhaps building bridges. So if you were to, like, you know, summarize this in a much humorous way, it is like a diagram like this. So it's like, we post the data on Bitcoin, and then there's some code that reads this data, and then there's some code that takes transactions and then executes and then gets into a new state of funds, and then just publishes new data into Bitcoin. So it is like, we're using Bitcoin as a, you know, sort of a database, you can think of it. Let's check how many minutes I have. Oh, I have quite some time, that's nice. So yeah, this is the idea of rollups. You basically publish your data so that you don't you cannot hide any data from public. They're all public. People can always verify it. People can always be synced into what you're doing, always aware of what's going on. And even further, like, they can also verify it using different techniques that I will come in a minute. So yeah, there are many rollups on Ethereum. Like, if you go to the, you know, this area, you will probably see a bunch of them as well. Like, so like, this is particularly because like the researchers and the cool people in the Ethereum world decided to do so. Like, they said, okay, these are the limits. The more secure we get, the slower we get as well. So let's do another chains. Let's bring these executions into, you know, off-chain, do these in other machines, and then just verify them so that we can agree that it's all true. So this is the whole idea of, you know, all these scaling solutions that you see all around in the Ethereum world. And there is no rollups exist on Bitcoin. It's like, there are some chains that utilizes Bitcoin in one way or another, but there is no chain today in the world that uses Bitcoin as a data availability layer, that uses Bitcoin as a source of truth. Like, we get side chains. Side chains are just, you know, your regular chains that work, and they post little data like hashes or some little data to the Bitcoin. But you know, let's say one day something bad happened, and then like for example, you protested against COVID, and then you became all of a sudden unwanted man, and then you wanted to use a side chain. The problem is, like, side chains may, you know, even worse, like, side chains may try to, you know, hold data and not give you data so that you cannot do transactions or anything like that. So there are no rollups exist on Bitcoin yet. There are some side chains, but we believe like theoretically rollups inherit the security of this other chain, so they're much more comprehensive and securer. So, and also like there's a reason for this. Like Ethereum has a bunch of rollups because it can. Like they're smart contracts. It allows heavy data posting. But if you look at the Bitcoin, then what you get is for example, Bitcoin script is an assembly-like language with many limitations. It is like you cannot post too many things because its block size is 4 megabytes in every 10 minutes in the average. So also like it is quite expensive. So per transaction you pay some fees, and the more data you post, the more you pay. So let's say you pay like, I don't know, 200 kilobytes, 300 kilobytes, then you pay hundreds of thousands, like hundreds of dollars or thousands of dollars. So like all this kind of stuff are the reason that rollups do not exist at the moment until like so, but luckily like the innovation never stops. So this is why we are here. So we are at Citrea team. We're building a rollup on Bitcoin. So if we were to go over it again, like in the first slide, I was talking about like these ideas like EVM compatibility, ZK-Rollups, and being on Bitcoin. So if you were to fast forward and check back, so Citrea is an EVM compatible chain that we are building. That means any kind of Solidity code will also work on Citrea because we are a Type 2 ZK EVM. That means like we're fully EVM compatible. Your smart contracts will continue to work on our ecosystem as well. So we are able to onboard many devs and onboard many protocols just directly, very easily, instead of being like alt VMs are also cool, but like we're EVM compatible in that sense. Citrea is a ZK rollup. That means we're also publishing zero-knowledge proofs and verifying them using Bitcoin. So there are two aspects that I want to talk shortly. Publishing zero-knowledge proofs is like, zero-knowledge proofs are kind of the execution proofs. It is like you basically write a simple program, let's say, and then you say for this particular input, this program just printing something like this. But people may say like you may modify this program, you may lie to people, how can I be sure that you run the exact same program in the exact same environment with these values and then you get these values? This is one specific use case of zero-knowledge proofs. And in the ZK, like they're mostly used for compressing and verifying executions and also for privacy reasons. Here we are basically verifying that Citrea rollup, like the Citrea chain, is working as intended. And here is a proof for this that you can find on Bitcoin. So we're also publishing this onto Bitcoin as well, so that people can check themselves and see that like everything is as expected. This chain is functioning correctly, and you can verify it on these, on your own local environment as well. We're also publishing the old data so that people can sync. And there's also Clementine. Clementine is our bridge. So bridges are kind of goes like this, if I were to simplify. Let's say I make a T chain, and then someone decides to make a chain A, and we don't know if I want to use chain A, I need to put some money into it, but I have money in my own chain, so how can I going to do it? Like, it's essentially bridges are like moving money from one environment to another because they cannot coexist in like money cannot be duplicated. It's not, it doesn't have quantum property, it doesn't have superposition or whatever. So the thing you do is like you basically trust someone or like use some algorithm to onboard your money from a platform A to platform B. And for this, we have Clementine. So in today's Bitcoin world, the way you move your money into other Bitcoin is you basically trust someone, you give your money into them, and then they generally don't steal, but there can be accidents. And you trust 5 entities, you trust 5 entities out of 7 or like 8 entities out of 9. We believe these are not secure enough because like if the stakes are too high, then like these designs are like, can be dangerous. In fact, like there is some controversy going on in the Bitcoin world that like, I don't want to talk very deep on this, but you can always search or we can talk later. So we're building a bridge. This bridge also does ZK verification as well. Like we verify snark proofs optimistically. We can talk details after this session. So essentially we're building a state-of-art bridge using the BitVM idea. And using this bridge, like people does not need to risk their custodial funds that much. Like it's still not trustless, but it is a trust minimized bridge that you can get the best today in today's world. And it's on Bitcoin. Like every data is on Bitcoin, every verification is on Bitcoin as well. So it is on Bitcoin, for Bitcoin, to Bitcoin. And this is sort of a hilarious draw that I made like 1-2 hours ago. It's like so the above chain is Citrea and below chain is Bitcoin. And what happens is like we publish the data of our chain into Bitcoin. And also when you want to move your funds, you basically use the Clementine. It is a ZK bridge on top of, it's a ZK bridge between Bitcoin and Citrea. And yeah, we basically optimistic verify ZK proofs. You only, there's a one-off and trust assumption. That means as long as one people is honest in the world, they can challenge. And as long as one people in the system is honest, then funds are secure. So you don't need to trust like 3 people out of 5 kind of setups like that. So there is always like, this is a huge improvement compared to, previous years. Sorry, I have 5 more minutes. So like we have a roadmap, and like in this roadmap, like this is an old version. So now we basically made the testnet live, and now we also have the atomic swaps going on. So we're basically expecting to be live in the Q1 of 2025, hopefully. So there are some slight delays to make sure that everything is working correctly and as secure as we believe so. So yeah, like this is how Citrea is, and this is how it goes. Oh yeah, one thing is bounties. So what are we doing? Like what are we here for? So we basically present 2 bounties here, and one of them is like the experimental DeFi bounty. So because we're trying to make a secure bridge, and because we're trying to utilize a BitVM-based ZK bridge, that means like we're basically making a much securer Bitcoin scaling solution today. And this is actually like, this can play a really huge part for Bitcoiners to, try to utilize the EVM world's ecosystem. And like on the EVM world, there are many like, different protocols. Like there are DEXs, there are lending borrowing protocols, there are yields, and like there's much more stuff going on, but like Bitcoiners cannot use these today. So when we go mainnet live, then ideally like they should be able to use some cool protocols to make these Bitcoins some revenue streams. Instead of selling their Bitcoins, they can just, stake it, or, give some loans using it and then take some USDT, whatever, these kind of solutions. So because of this, we need cool DeFi ideas. And one track is particularly for this. So, if you have a cool DeFi idea that Bitcoiners can heavily utilize, it's just EVM code at the end of the day. Just try to, optimize it and submit so that we can get use of it, and like there's going to be like there's a bounty for this, and like we can talk even further for it. We support cool builders to make companies and grow bigger as well. And the other one is particularly for Bitcoiners. This is a very specific track using the Bitcoin verification contract called Bitcoin Light Client. So if this kind of sounds great for you, then let's talk quickly after this session. Yeah, I guess this is the end. So one particular example, if I have some time. Yeah. Thank you. So if there are if any questions, do you guys have? Yeah, there is one question, but I don't know how can I hear. Oh, okay. So how can I hear a question? Maybe you can come and then I can repeat the question and answer. Or okay, let's talk later as well. Okay, let's talk later after the session. Okay, all good. One thing that I could show you is how easy it is. This is just regular EVM code that you see here. If I were to make the theme white, just you can see it easier. Yes. Oops, sorry. My internet is probably bad. Yes. So you can just use your existing IDEs like Remix, you can use Forge or whatever that you daily use in the EVM ecosystem to deploy smart contracts. Any of these codes also continue to work. Just some simple. If you were to open our testnet smart contract, it is just a regular smart contract that is also going to work on the other EVM environments as well. So if you're proficient with Solidity, if you know Viper or even Yule, you can just deploy those smart contracts and then go from there for this particular track. We have some documentation to kickstart this stuff. So if you go to our documentation and then check the deployment guide, we do provide some real short explanations and concise explanations on how to kickstart it. But you can always check more, ask GPT, just build stuff that works so that we can give bounty to you. And yeah, this is just the way to do it. And you can also deploy contracts using Remix by compiling it and then going for MetaMask and then deploying from here. So this is just the regular environment. So yeah, I guess this is the end of my session, and thank you all for listening. And I hope you all have a great hacking environment and hacking days upcoming. So yeah, thank you.